Alright, so here's example 2 with the power rule. We have g of x equals the square root of x. Now we want to find g double primed. So square root of x, how does that apply to the power rule? Well, remember square root of x, that's just the same thing as x to the 1/2, right? And now that we have the general power rule, we can talk about any power of x. So including irrational powers like we saw in the last video where we had x to the pi, or fractional powers like x to the 1/2. So we want the second derivative, and to get there we have to go through the first derivative, right? So let's go ahead and do that. So g of x equals the square root of x, which is just x to the 1/2. So that means g primed of x is going to be what? Well, x to the 1/2. So remember the derivative of x to the r is just r x to the r minus 1. So in this case, our value of r is just 1/2, right? X to the 1/2. So what we're going to have is 1/2 x to the 1/2 minus 1, like that. Okay, so we want to simplify a little bit, and what we're going to have is equals 1/2 x to the negative 1/2, alright? And if we were going to stop here, we'd want to simplify that and say, okay, that equals 1 over 2 x to the 1/2, right? So we have a negative exponent here, and so we can write it like that, and then even better, we could say 1 over 2 root x. So actually the derivative of the square root of x is 1 over 2 root x, right? But remember, we want the second derivative. So to get the second derivative, this is nice and simplified here, but it's actually going to be easier to use this form here because this is already, constant times a variable to a power, right? But this, of course we could just take this and rewrite it as this, but this is just a little more complicated because there's that extra step. So because we're not stopping at the first derivative and we're going to go to the second derivative, let's not do that in this case, and let's just go ahead and keep going with this. So then g double primed of x equals, so here we have a 1/2. It's just a constant being multiplied by all this other stuff here. So the 1/2, we'll just pull it out of the derivative. So we're going to have 1/2 times the derivative of this guy. What's the derivative of this guy? It's negative 1/2. Okay, negative 1/2, and then times x to what? To negative 1/2 and then minus 1. All right. So you might be wondering, shouldn't these parentheses be not like this, but should they be like this? And it actually doesn't really matter. The only reason I put parentheses here was just to avoid any confusion with this minus sign in here, because it's 1/2 times negative 1/2, and then times x to the negative 1/2 minus 1. Okay, so when we simplify this, what are we going to get? Well, 1/2 times negative 1/2, that's negative 1/4. And then what happens here? X to the negative 1/2 minus 1, what's that? Well, 1 is just 2/2, right? So we have negative 1/2 minus 2/2, that's negative 3/2, right? So depending on what you're doing, or who your instructor is or whatever, this would probably be an acceptable answer, that's fine. But if you had to simplify a little further, you could say, negative 1 over 4x to the 3/2. Or if you wanted to go even farther than that, x to the 3/2, x to the 3/2, that's x to the 2/2 plus 1/2, right? So that's the same thing as saying x to the 1, okay, 2/2 is 1, times x to the 1/2, or in other words, x times the square root of x. So x to the 3/2 is the same thing as x square root of x. So you could also write this as negative 1 over 4x root x. And that's definitely, much nicer to look at, but depending on whatever you're doing, this would probably be fine. But anyway, here's 3 different ways of expressing the answer here.